Okay, time to get started here. I have a little bit of voice left. I'm going to do the best I can with it. As usual during the air shows, it's pretty much shot by the third day, and I'm living up to its tradition. But I'll do the best. If you're having troubles here, let me know. I'll either adjust the mic or try and talk clear. The presentation we're going to do today is called Affordable Flight for All, and we're going to introduce the airplane, the EMG-6, our latest adventure here. Try that.
This is test flight number 55 and 56, and we are testing the operational characteristics of the power plant system after our
try this instead. Ta-da, we did it. Okay, back up one slide here. Okay, I'm going to do a little introduction for those of you who don't know who I am. My name is Brian Carpenter. I'm the CEO of Rainbow Aviation Services and Adventure Aircraft. Adventure Aircraft was a subsidiary company of Rainbow Aviation, formed primarily to be able to pursue this electric aircraft venture. I'm a commercial pilot, CFII, sport pilot examiner, got about 8,000 hours on over 300 different type aircraft. ANP, EAA, LSRM, DAR. I've built 43 aircraft total so far. We're the company that produces the light sport repairman maintenance classes around the country, with over 4,000 students now having attended that. My wife and I are both authors and aviation speakers, and we talk throughout the country at different events. I'm an EAA flight advisor, tech counselor, and founder of Chapter 1148 in Corning, California, where our home base is. And we've been a long time involved with EAA right now, and do everything we can to support them. You may have seen the EAA home builder tips, which I try and participate in as much as I can, and we'll be doing some more of those here if I have any voice left at the end of the show. We're the winners of the USUA Moody Award in 2007 for excellence in ultralights and light sport aircraft. So the talk I'm going to talk to you today about is the dilemma that we have in aviation. And it seems to be this reoccurring dilemma, but it's getting worse and worse as time goes on. The cost is getting to the point where it is really almost unattainable for so many people. We have the cost of flight training, cost of insurance, cost of storing an aircraft, cost of fuel, cost of maintenance, cost of financing, cost of retaining your medical, and of course the cost of the aircraft is one of the bigger elements that we see all the time. One of my favorite airplanes here in the whole world, if I could have a light sport airplane of my choice, I'd choose the little Techman here. I think it's just one of the most delightful little light sport airplanes that we can fly out there. But for most of us, we have decided that $172,500 is not exactly an entry-level price for most of us. That's really what we're seeing out there in the industry, is the prices on most of these light sport aircraft is well over $100K. That is not a starting level for most of the people in the world that are trying to get into flying. And so we've looked at really what we need to do to invigorate aviation, and that invigoration of aviation requires that we have more people involved with that. And if the price of all of these things becomes intangible, they simply don't participate anymore. They just sit on the sidelines and watch everybody else do that. So when we started down this path of trying to idealize what we think is necessary in order to be able to get more people involved with aviation, we came up with these criteria that we have right here. Now remember, we're not intending to solve all the problems in aviation here, but rather one of the problems, and that's the entry-level aviation. And so we've thought about this a long time, and we've come up with these 9 items that we think are the most important. First one is that we think that revitalizing Part 103 and having just a very basic entry-level way to get involved with aviation without all of that cost of a check ride and extensive flight training. If all you want to do is go fly around the patch, it really seems, as a student pilot, it seems ridiculous that you need to be learning about ADS-B and how to fly in and out of Class B airspace in San Francisco International. It just doesn't correlate for the average pilot. He simply wants to get out there and fly. Most pilots that start off in Part 103 ultralights eventually end up moving up to sport pilot and private pilot, commercial pilot, and so on. I can't tell you how many of my friends that started with me 40 years ago flying in these little airplanes are now flying corporate pilots. They started out as an ultralight pilot. They're now flying for some big corporation, flying a Learjet or a Citation or something like that. It's all a stepping stone. But if we can't get that first step, it's never going to happen. And so we believe that Part 103 is one of those answers that we're looking for. We have been looking at this electric power for a long time, and we are truly zealots about this. We have analyzed this from inside out. I'll talk a little bit about really where all this is now and where it's going to be. But we believe that in 10 years you will see, especially in the ultralight area, we will see more electric airplanes out there than we will see gas-powered airplanes. And we believe that we are on the cusp of seeing a significant paradigm shift in terms of how little airplanes are flown. We'll talk more about that. Safe and easy to fly, good performance, folding wings, low cost, simplified construction, an aesthetic design, and a marketable product. Those are the things that were on our list. So I'm going to talk about each one of those individually. And this was kind of a rendering in the early days of what we thought we were going to have that met all of that criteria. This actually is a joint venture. Quicksilver Aeronautics, which is the oldest ultralight company in the world, they build about 20 to 30% of the parts for me. And we have been Quicksilver dealers in the very early days. We were back in the days when we were flying little 15 horsepower Yamaha Quicksilver Model E weight shift airplanes. And we go back to Quicksilver for many, many years. So Part 103, we've decided that's a very important aspect of the thing. The airplane that we have at the show that's down in the ultralight area is a legal Part 103 airplane with a 20 horsepower sustainer motor, 4 battery modules. Without the ballistic parachute, we're right exactly at 254 pounds, and with the ballistic parachute, a little above that, but that's freebie weight that we get on that airplane. Basic specifications on the airplane are that it is a 37-foot wingspan. This was a significant part of the criteria. If the airplane cannot fit in a regular 40 by 40 hangar, it would be too much hassle for most people. If you have to fold wings every time that you go flying, that becomes unacceptable. So we elected, rather than to have some high performance glider, we wanted to stick with an airplane that had really good results that met all of our criteria. And one of the things is it has to be simply able to put into a regular 40-foot hangar. It does have 170 square foot of wing area. That gives us a really light wing loading on the thing, as you can see, at a 750 pound gross weight with an aspect ratio of 8.2 and a span loading of 5.5. The span loading is really the criteria that determines whether or not it is a glider or not a glider. And in electric powered aircraft, right today, it's not practical to have an electric powered airplane. It is, however, practical to have an electric powered glider. And the reason for that is, if it's an airplane, the FARs say that you have to have 30 minutes of reserve fuel on board the airplane. Well, that's ridiculous to be carrying around, 80 pounds of batteries just so that you can have that reserve sitting there. In a glider, there's no requirement to have the 30 minutes reserve. And as a result of that, we can use up all of the energy that we have stored within the batteries on board the airplane. So it's much more practical to go glider at this point until the battery technology catches up to where airplanes really do make a lot of sense, and we'll talk a little bit more about that. Electric power, of course, we've decided that electric power, looking at the future, we can foresee that electric power is going to take over. Right now, we're a little bit simplified. This is a sustainer motor. That is a Predator 37. That's a 20 horsepower or a 15 kilowatt motor. It puts out 99.3 pounds of static thrust as it sits right there. We, to sustain flight with the thing, carry about 65% power without overheating the motor to be able to maintain level flight. That's where we are with that motor right today. It's not a self-launcher motor. That would be one of the next versions of the airplanes. Right now we have 3 airplanes. We have the prototype that you see at the airport that all the flights have been done on, and then production prototype number 2 and number 3. Number 3 is at the show also. And those are getting different versions of different motor power plant packages as we speak. And so the next generation that we're looking at is the airplane is actually built as a twin engine a tri-motor, a single engine, or as a pure glider. It can fly in any one of those three categories, and it was designed that all of the power plant systems are modular. We have recognized that the advancements in technology around this electric power right today are changing so rapidly, it'll be like your laptop. The minute that you put down your credit card for your new laptop, they've just put out on the shelf a new laptop that's better, isn't it? I mean, it's constantly evolving. We have made the airplane from the beginning to be able to leverage all of this new technology and make it very simple to pull off the latest version that you got and put on the newest version that you got. And so we expect this to be a modular, changing, evolving system for the next 10 years on quite a regular basis. There will be some of the power plant systems that are developed that will rise to the top, will be better than others, kind of like what Rotax has done in the industry. Rotax right now in the light sport industry holds about 85% of the market share. That means that 15% of the market share is shared by all the other engine manufacturers, Continental, Lycoming, Jaguar, HKS, They all share 15% of the market share. Rotax, because it got out early and it became part of this process, now has absorbed the entire community, and it has the best product, and it can continue to evolve and get better at a faster pace because it has such a market share. We will see a couple of electric motor developers probably do that as well. Here is the Nova 15 and the Nova 30. The Nova 30 is the self-launch motor we will be using on the prototype number 3, the production prototype. It is a 30 kilowatt or 40 horsepower engine. It's operating about 93% efficiency. To give you an example of where we are in the industry right today, 40 horsepower motor, Nova 30. The equivalent in a gas-powered engine would be the Rotax 447. The Rotax 447 is a 40 horsepower engine. This is a 40 horsepower engine. This has 1/3 more torque. The Rotax 447 with a V gearbox and electric starter weighs 93 pounds. That motor right there weighs 11 pounds. By the time we add cooler and ESC and all that stuff, we're at 20 pounds. That leaves me 70 pounds of batteries before I even get to zero fuel weight on the gas motor. So the advantage that we have in electric power is rather than the best gas engines out there where we are 1 horsepower per pound is where the state-of-the-art is with gas engines right now. In the electric engine development, we're really very close right now to 4 horsepower per pound. A 4-fold increase in power to weight ratio coming out of these engines. The downside is the batteries, of course. So let's go back to our comparison. If we compare those two engines and we have 70 pounds of batteries before we get to zero fuel weight, and then we add gasoline and more batteries to where we stay equitable all the time and we eventually get to equitable flight time, today, right now, that number happens to be right at 23 minutes. So if you're going to fly shorter than 23 minutes, you can see that it far outweighs the favor in favor of the electric motor because you don't even have any gasoline to go flying with, so it's very easy. That's how the model industry, if you've gone to a hobby shop lately, you will notice, guess what, all the gas model stuff is gone. It's all now electric stuff. For short periods of flight time, electric has taken over and will continue to take over those short flight times. So when we have a glider, where we're towing the airplane aloft, high beam, and we pull the airplane into the air, we typically right now tow the prototype. We have a little Honda 400cc four-wheeler, hook on a 1,400-foot rope, and take off down the runway, and we'll tow to 1,000 feet on a consistent basis. We can tow with any vehicle. We've done about a half dozen vehicles right now that we tow with. But we now on 1,000 feet, we turn on the sustainer motor and we fly around. If we catch a thermal, shut the motor down, the props fold up, we go thermal for a while, and after we're done thermaling, we run out of thermal, or we flew a little too far away from the airport to get back, we just power up a little bit and zip on back. That's the kind of platform right now where if we have 23 minutes or less of mission flight time where we need to be under power, that idealizes itself for electric power. Anything more than 23 minutes, gasoline still blows the doors off it. The energy density in gasoline just doesn't compare to that of battery power. And it's getting better. 10 years ago, that equitable flight time was really right at about 5 minutes. Now we're at 23 minutes. Give us a couple more years, you're going to see this stuff change. It isn't that we don't have the technology. We have the technology to blow your mind right now. But we don't have commercialization of that technology, and that's really where the downside is. Everything you see flying in the prototype aircraft right today that's out there at the air show, it is off-the-shelf model airplane stuff without any exceptions. Everything, propeller, motor, controller, batteries, all of that is giant scale RC model stuff that's flying that airplane. You can go get your credit card and order everything that we have right there off the internet right this second. And that was our goal right to start with. We teach the light sport repair and maintenance classes. When we teach that class, one of the things that we teach all the time is that all of these new manufacturers of new products that are building these different engines and reciprocating engines, we find that every product that's new is really the greatest product in the whole world. And the reason for that is we don't have any experience with the thing, and so there's no failures. As long as you never fly a product, it's a great product. But the minute that we start giving it to a bunch of bozos and they start screwing the thing up, we start to see all these failures. It really does take about 30 years to go through and develop a product to the level where Rotax is today with their 912. That's why nobody else can catch up with them. That's why the new guys are having such a hard time. Well, we're using this philosophy in electric motor too. We know all this new electric technology is still going to have to go through those same processes. When we have chose to use the model airplane industry stuff, we have already mitigated some of that because these model engines are being used throughout the world in the thousands. The ESC, the controller, the propeller blades, they're all proven. We don't have to do that R&D. And you'll see the models, you'll see the aircraft that are flying electric right now. Lots of failures because it's all new, one-off equipment that's out there. It'll take many years for us to finally work this stuff out. Big improvements over the last 4 or 5 years, but we're right now operating with some known, proven quantity. Not a lot of surprises for us so far. It's working really well. So that's kind of where we are in the state of the art right now. When someone says, oh, I want to go fly 3 hours, I just tell them, don't buy this airplane. It's stupid. Right now, 23 minutes is the magic number. We know that you can do better with gasoline, anything more than 23 minutes. If your flight mission is really that you need to go on a 4-hour flight, this is stupid right at this point. As we develop, some of these guys that are working with this project are really interested in developing some hybrid versions. You know, I've heard some of the craziest stuff in the world. You know, we're going to put a turbine engine in there, driving a generator that charges the batteries, that runs the motors, that, okay, let's see what happens. But we really are not interested in being the end source for the motors, controllers, batteries, and all that kind of stuff. We don't have enough volume to do that. We thought it actually was going to be the car industry that was going to drive the battery technology. You know who it turns out is doing more adaptive, innovative research and development towards batteries on the commercialization process is the cordless tool manufacturers. There's just billions of these things being sold around the world. And every Christmas you notice that the battery packs on those drills get smaller and more powerful and last longer. Those guys are really going to town and developing some of that stuff. And I think we will see more and more commercialization. When we get to that point, we'll be able to start leveraging that. Safe and easy to fly. That's never good at an air show. So, safe and easy to fly. You remember our first criteria is that it had to be Part 103. Well, Part 103 is ultralight. No requirements for pilot's license, no requirements for training, all of that crazy stuff. I grew up in the days when we started training in Part 103 ultralights. It was transition from power, basically hangliners that got power. In the early days, there was no such thing as a two-place airplane. And so what we did is we'd get an old Quicksilver Model E weight shift, we'd give them a couple hours of ground school, we'd put them in the airplane and send them off. If they came back, they were a pilot. If they didn't come back, we got a new student. And that was kind of how the system worked. Well, that's really not an acceptable method by which to transition pilots into ultralight aircraft. And so one of the criteria on the airplane is that it had to be a really easy to fly, safe airplane. And as a result of that, we have to give up some of the high performance. You know, the snap rolls in this airplane are probably going to be kind of wimpy. We're really looking at stability and ease of flight and safety and all of that. This was test flight number 39. This test flight was specifically for the purpose of demonstrating the hands-off flight capability of the aircraft. And we've got a camera plane flying out in the distance out there. They're getting prepped to do some. It's kind of funny because they flew along as I took off, and they're climbing at max rate of climb right now. When we tow, we typically tow at 40 miles an hour, and we can be towing right at 1,500 feet as a routine. Our highest tow rates right now have been at 1,800 feet a minute on the tow. Very aggressive tow. So we get to altitude, and this is purely a glider mode. You can see the propeller in the back, they're all folded up. So we're just gliding during this flight test right here. Very flat glide. And we're just waiting for the camera plane to catch up with us right now so we can take some pictures and some video. This airplane is so stable. If you lean all the way forward, the airplane will go to best glide speed. If you lean all the way back, it will go to minimum sink speed. You can lean all the way to the left or all the way to the right, and it'll bank about 5 degrees, and that's it. As soon as I find a parachute, for me, the airplane has a parachute on it. One of our tests that we want to do is we want to get some altitude, 4,000 or 5,000 feet, and I plan to unbuckle and stand on the seat and hang outside the airplane. The airplane is that stable to be able to do that. And that'll make a nice video if you can see me crawling around on the outside of the airplane. Okay, we'll advance forward here. I think that will. The airplane has the ability built into the airframe to have a BRS parachute mounted in the thing, and on the prototype, because we're really expanding the envelope and testing the airplane to a great extent, there's a BRS 750 parachute that is mounted in that, and BRS has helped us with the harness and all of that. It's a 4-point harness right onto the main cage. The airplane will come down perfectly flat under the canopy at a really low sink rate. Speeds, best glide speed is 40 miles an hour. Minimum sink speed is 35 miles an hour. Stall speed is 23 with the flaps up and 18 with the flaps down. Our max tow speed right today, until we expand it a little bit more, is 60 miles an hour, and the airplane is designed at 90 mile an hour VNE. Now, at best glide speed, the glide ratio is 13 to 1. And the glider guys all say 13 to 1, that's pretty horrible. That's not that great. That's actually right about in the area of an intermediate hang glider is where that is. But what you have to remember is that glide ratio is altitude lost over distance. If you're going somewhere, glide ratio is really, really important. That's why those guys with those fast fiberglass gliders do those long cross countries. Very efficient, real high glide ratios on the thing. The most important thing for this airplane is not best glide, but rather minimum sink. And we're right at 280 feet minimum sink right now. That's better than the Schweitzer 233. That's the kind of airplane where you can now thermal really efficiently. And as you saw in the video, the glide is really, really flat on that thing. It's not coming out of the sky very fast. And so one of the guys said, well, we really need a higher glide ratio. And he was in the booth talking to me, and I said, well, it's actually 80 to 1. He said, that is not 80 to 1. There's no way to get 80 to 1 out of that. He says, yeah, I do all the time. He says, that will not get 80 to 1. You start to get a little indignant. And I said, I do it all the time. He says, how is that possible? I said, all I do is I reach down with that little thumb switch and start adding a little of that electric power, and the indicator just goes right on up to 80 to 1 as soon as I get that throttle pushed up enough. I can make this thing act like any kind of glider as long as you've got a little supplemental power there to back you up. And so it was kind of tongue-in-cheek, but the reality is, when we're using this as a glider, just a little bit of power really improves the performance. And so right now, even with our small battery pack, in a sustainer mode with no lift, no thermals, we're still about 20 minutes of flight time in the air. That's a long time. So I heard like Malcolm at Wallaby Sky Ranch, where they tow the hang gliders down there. And he was saying really what we need in the industry is we've got all these guys that are towing behind the Noise Dragonfly. We tow them to 3,000 feet, they catch the thermals, and they fly around for a couple of hours before they come home. But we've got all these old guys, their landing gear are not as good as they were when they were 19 years old, and the thought of landing on your feet at 80 years old just doesn't work for them anymore. If we've got an airplane here with wheels where we can take off the wheels and land on wheels, those old guys that no longer can do the hang glider stuff can participate this with other. And he says, I don't even need 20 minutes, I need 10 minutes worth of flight time on the motor, because we're going to tow them up, they're going to do 2 hours worth of thermaling. All we need is have a little supplemental power that if they get a little short on approach, just add a little power. Or if they're out seeking a thermal a lot further than they should be from the airport, power up and go back to the landing area. So that's their goal. They don't even want to think of the power, the electric power part of the whole thing as part of the equation. It's basically to them a backup system to the flying of the airplane. So many different missions that this aircraft can be in. These are takeoffs. So Austin is my shop manager's 14-year-old, and I started having him run the wings. And as you saw in the video, I didn't realize that he was just holding on until I took off and he just let go of me. And so now we're at the point where we realize finally that we don't need any help on the wing runner. As long as there's no wind, just put our feet out and go. So pretty short takeoff and landing distances on this thing if we want to. By the time we're about 10 feet, got total control on the airplane. What happened? Yeah, I talked about the glide ratio and the sink rate.
So are you ready to run, Carl?
So on board the aircraft are 3 flight data recorders. We have the asset vario. That's basically a handheld variometer. It gives us a whole bunch of data, downloadable, GPS position, all of that kind of stuff. We have an Eagle Tree flight data recorder that does engine and battery temps and motor temps and all of that kind of stuff. And then we have an ESC that's doing controller motor temps as well. So we got 3 sources of data that we're downloading. Occasionally on the website, you will see Daniel, our motor guide, and I'll introduce you to him at the end here for questions. But he compiles all of our data for us and outputs this stuff, and you can see the actual data plots coming out of the flight data recorders on the airplane. So what we've done on this flight is we're showing, we've got rate of climb over here. Right now we're about 1,200 feet a minute rate of climb, glide ratio, altitude, GPS tracking position, and then airspeed up there on the left-hand side with digital airspeed. We've got digital airspeed and altitude, actually about 20 functions in those instruments. So we tow to altitude. So on this flight right here, we're 300 feet above sea level, and you can see that we're dropping off right about 890 or so. So that's about 600 feet above the ground for that launch right there. So we're at the end of the runway and we cut loose at 600 feet AGL. Normally that's a pretty short flight for a glider, 600 feet to make a flight around the patch. And so you can look on occasion when the video gets good enough, you can watch the glide ratio right here. This video is on the YouTube channel also, so you can go scrutinize our data that we've got right here. And vertical speed over there. So we're able to take off from the end of the runway. We're right now come alongside of the runway right now. We will fly down past the end of the runway over the high school. We'll make a 360-degree turn and we'll land in exactly the same spot that we took off from. The these are all glider tows. The first 50 flights on the airplane were all ground launch. And we didn't do any power stuff until just recently. We've done 5 powered flights so far. Every flight that we've done so far is all flight test program stuff. We've got a very specific series of tests that we're doing, and we're just knocking them out one at a time. Very, very specific program flight test on the thing. Yeah, it doesn't show up too good on this screen right here. But now we're getting ready for the landing, starting to circle down. Very easy to fly, very fun to fly. On the website, we also do a progress log. So we keep you, when we're in the shop, we do a pretty close update on a daily basis of what's been happening, all the flight test stuff. We show the bloopers from the screw-ups on the flights and the screw-ups in the shop. Pretty much everything that's going on within the shop. Folding wings. The airplane has a very unique folding wing design. It is designed so that the entire package can fold up, the tail folds up. None of the controls on the tail have to be disconnected to fold. They just simply fold. The wings fold down alongside the airplane. When the airplane is folded, with the wings in the folded position, the total width of the airplane at the widest point, with the exception of the training wheels here, is 33 inches. It's a very, very narrow package. It will go through a door of a house. Go through a regular house door with it in a folded position. That was one of the criteria. The ability to be able to afford an aircraft means that I've got to have some place to put this thing. I've got to be able to have something where I can either slide it in the hangar with my buddy and I'm not going to use up too much of his space, or I can take it home, put it in my one-car garage. That was one of the criteria right from the very beginning. We need it to be trailerable. Low cost. Plans build option we think we can do for less than $10,000. We got a couple guys that are started on that already. Kit build, $12,000. Got to do a little welding, and the fast build is basically an erector set at that point. Simplified construction. We have done some amazing things with the construction of this thing. The entire airplane is designed using SolidWorks with full 3D modeling, finite element analysis capability. Each one of the tubes, there's a set of plans. Each one of the tubes, if you're going to do a plans-built version, it points to the tube. On your home computer, you simply print out this in 100% scale, cut out the template up on the top, cut the tube to the length. In this case, this tube is 24.4 inches long. We draw a line down the center of the tube. Usually we just take a U channel and put it on the tube. That aligns it perfectly straight, magic marker. Wrap the tube with the template, slide it down to the end, magic marker around the end, slide it to the other end, magic marker, grind it on the grinder. It fits the airplane exactly perfect. If you've ever done tube welding and you grind a little, you go fit, you grind a little, you go fit, and then by the time you're all done ready to weld, there's this big half-inch gap that you're trying to fill with the torch. This is just amazing. The 3 prototypes that we have right now were all built using this system to prove that it works. We even have jigs that can be built to hold all of the frame members in place. Those jigs are actually made out of MDF. We have DXF files that you can take down to your cabinet shop and give them the DXF file and 2 sheets of MDF, and he will cut all the jigs on the MDF. Usually costs you about $200 for a complete set of jigs on the thing. The jigs can be used probably about 50 times, so we've got guys that are going to make all the jigs, and then they'll just sell them to somebody else for 3/4 of the cost, get their money back, and the next guy can buy them, and he'll sell them for 3/4 of the cost, and so on. Make use of many jigs on there. There's an example of the MDF jigs for the wing box, one of the more complex parts that are in there. The fuselage is 2024 T3 match drilled aluminum. It is simply pop rivet together with stainless steel pop rivets. We haven't done it yet because we have Clecos, but we have designed it with the intent that you don't even need Clecos. It is such a close, nice fit. You just simply start pop riveting parts together and it all lines up perfectly. It's just amazing. The last boom fuselage that Jason put together, 4 hours start to finish on the boom fuselage. Just start popping it together. a little bit of deburring on the holes. Simple, proven design. The wing is actually slightly modified Quicksilver GT400 wing from Quicksilver. We're using all of their fittings and all of the engineering from the original GT400. We've got a little bit stronger spars than what they had. On the ultralight version, we're sticking with the same spar size as what Quicksilver had on the original GT400. Aesthetic design, we really like it. We have all the molds right now for the carbon fiber fairings and the windshield and all of that stuff. We don't have it on the prototypes at the show yet. We still got some work to do in that area. The airplane is designed as a single engine, twin engine, or tri-motor configuration. The nice thing about electric power is you can do distributed power real easy. Because the motor's only 5 pounds, you can put it out here and power it in a remote location. That's why you'll see some of these new technologies where guys are using 16 electric motors to fly the thing. Or that little eVolo helicopter. Little motors all over the place on that thing in order to be able to fly it. Marketable product, of course. If we can't make any money, this project right now, I keep telling everybody, it's kind of like if you had a fire hose and it was shooting $100 bills. That's what it feels like doing this project. I mean, it'll discourage you at times. This is another really neat option. I already talked to you about the hang glider community using one of these for the guys with the bad landing gear. Right now, most people are not aware, but the operating limitations in SLSA light sport aircraft and ELSA light sport aircraft include in the operating limitations to be able to use that aircraft for towing for hire. Your experimental light sport aircraft can be used commercially, charged for the use of that airplane to tow gliders aloft. It's right in the operating limitations. It was one of the little caveats that came about in the whole rulemaking because we had all of these Moy's dragonflies towing hang gliders and they wanted to allow that to be able to continue. We've never seen this done very much except in the hang glider community because we haven't had any of these type of gliders before. And we've never seen any other aircraft used for this because the only aircraft really that's effective for towing hang gliders that can fly slow enough for a hang glider on tow is the Moy's Dragonfly. Well, now we're talking about a glider with a tow speed of 60 miles an hour. Pretty much any light sport airplane that you've got out there, perfect for towing these things along. So now we can envision where we have a little flight school set up. Remember that these airplanes are all two-place airplanes. If you build it as an ultralight, it's a good build, and you just won't use the second seat. That's where the batteries go for the motors. And we only have 750 pounds of gross weight. So if you're going to use it as a two-place airplane, the primary purpose for that is so if you're the builder of the airplane, you can take, and we have flight control systems that go into the back seat that are removable. So you can take an instructor, throw him in the back seat, tow the aircraft, aero tow, get yourself 3,000–4,000 feet, and spend a half hour up there doing flight training, and do that enough times to transition the pilot safely into that airplane to where they're comfortable. Not the old days where we had to send you off and hope you came back kind of deal. So the whole purpose for the two-place wasn't that this is a real two-place airplane, but we really truly have a viable two-place training aircraft in a pure glider configuration or a powered configuration without the batteries in the back of the thing. It's a powered airplane. The motors don't weigh anything. It's the batteries that weigh something. So simply what we do, take the batteries out. They are designed very specifically to seatbelt into the airplane. One of the things that happened is 3 years ago, there was a controversy. There was a lot of electric ultralights out here. There was a controversy over the reading of the rules in Part 103. Everybody was interpreting the rules to say that it says you can have 5 gallons of fuel. And people were saying, okay, that means 5 gallons of batteries. Great premise. However, because of our light sport repair and maintenance classes, we deal with the FAA both at Oklahoma City and Washington, D.C. level, and they were giving us feedback that that may not in fact be true. So we sent a letter to FAA Legal, and a couple of years ago that letter came back, and the ruling from Legal said that because the batteries are permanently mounted in the aircraft, they are not considered fuel and therefore must be considered part of the 254-pound empty wing. Well, that blew the doors off everybody's plans, including our previous project, the EMG-6. batteries are the big holdup. But we've reorganized with the EMG-6, that airplane that you see at the show right now, with the 4 battery modules, the 20 horsepower sustainer motor, without the ballistic parachute, is 254 pounds. It's legal with the batteries in there. Since then, there has been a lot of talk about this whole rule, and it says very specifically that if the reason that the batteries have to be considered part of the empty weight is because they're permanently mounted in the aircraft. So we very specifically designed the aircraft so that the batteries are just simply seat belted in. There's some little pins, they pop in place, put the seat belt over them. They are no longer permanently mounted in the airplane. In fact, we can reconfigure small batteries, bigger batteries, bigger batteries, bigger batteries. The airplane at 750 pound gross weight has the capability of 3 hours of flight time. That's stupid, but it does have the capability of 3 hours of flight time with enough batteries to keep us under gross weight. If you're going to fly 3 hours, you need a gas-powered airplane. And with this, now we're totally legal, and we now believe that we can go to the self-launcher motor, claim the batteries are not part of the empty weight, and we can still meet Part 103 regulations, and that's where we're headed right now with the next one. We'll fly it as a Part 103 with a self-launch motor and be legal with that thing. But the towing option, I'm telling you, think about this. You've got an airplane, you can build this thing, and right now, there's no such thing as light sport electric motor glider. In fact, there's no electric light sport airplanes. And the reason for that is the FAR say that the airplane has to be a single engine reciprocating engine. So that blows out the rules for all of that. There's an ASTM standard for electric right now. It's written, it's approved, it exists. They're using it in Europe. We're just waiting for the FAA to finally adopt it and allow it, change the FAR so that we can use the ASTM standard. Pipistrel right now has an electric airplane that they are wanting to sell in the US. Just can't do it until the FAA gets their, there's no sense even arguing why it takes so long to make this stuff happen. The Europeans and many foreign countries are blowing the doors off the US in terms of development of all of this electric stuff. The U.S. is actually further behind than just about anybody. It's really kind of a sad state of affairs. But we do know one thing, and that is that it's going to change. And at some point, we will now have ELSA and SLSA airplanes. We are designing and building the airplane right from the very beginning to intend to certificate the thing as an ELSA and an SLSA at some point in time once those rules change. Right now, we're flying the airplane as either ultralight category, Part 103, or experimental amateur built glider. And that's the 2 categories under which we fly. You can use it for flight training. If you're the builder of an airplane, you can put an instructor in the back seat, and he can charge for his services in the back seat of your airplane all day long. You just can't charge for your airplane as an amateur built aircraft. So we've got a viable training platform right today, and what we expect to see happen is we'll eventually have some of these that we could put into commercial use for glider training. And think about this, an off-the-shelf SLSA pure glider that we can charge and use for our services that you are buying for less than $30,000 as a 2-place glider in the current market. That's a totally viable concept out there. These airplanes at $150,000, boy, you've got to do a lot of fancy stuff to make up the difference. And what we're seeing is we've got the absolute perfect platforms now for towing, much better than we've ever had before. In the past, we used to fly with Connees or these air-cooled Continentals and Lyconies. Brutal environment, hard climb where we're getting not enough cooling, where we need the maximum amount of cooling. And then on the descent, we're shock cooling, the motors are just blowing them up. Real short lives on glider tow planes. Now we've got 912 powered stuff, a little 80 horse 912 burning 3 gallons an hour. Doesn't matter. It's water cooled, the temperature's stable. You yank the power all the way back, it's like a friggin' turbine. You can do that all day long. You'll still, even in a tow operation, get 2,000 hours out of something like that. Perfect platform, low-cost tow plane, low-cost glider. We can really now start doing some significant training. And the cost of an airplane, basically $15,000, that's doable for a lot of people. You come to an airport, get a little bit of flight training, buy their own airplane, even get flight training in their own airplane. And in fact, we think this is where one of the significant advances is going to go. Example of a tow plane that could work real good. We actually have a video. We tried to tow the airplane with a Quicksilver Sport single place with a Biltex 447. That's 40 horsepower airplane. And Bill, my father-in-law that owns the Sport, 250 pounds sitting in that airplane, and my fat butt in a glider, and we towed off the ground with that thing. Got in the ground effect. I got out pretty easy with the glider, cruising along. And then he finally breaks in the ground effect. And I'm a little too high, so I start to descend, and he starts climbing. It's looking pretty good. So I start climbing, and he goes back down. Wasn't a lot of climb rate left in the whole program. 40 horsepower for 2 airplanes, pretty marginal. But we thought, boy, that would be awesome if we could actually do it. And we would have made it around the patch. We were climbing, it just wasn't safe enough to continue. So I boarded at the end of the runway, and he went around. We made 2 attempts at that. It wasn't ever going to go anywhere. We need a little bit more horsepower than 40 for 2 airplanes to fly into the air. So the airplane, like I said, is a 2-place airplane. And if you're carrying a small passenger, like a kid or something like that, you could be doing power. You just have to work within the 750-pound gross weight limitations on the airplane. So if you're carrying a 100-pound kid, you can get 100 pounds of battery. It would work in that configuration pretty easily. To fly as a glider, if it's a single place experimental aircraft, whether it's multi-engine or glider, you don't need a glider rating, you don't need a multi-engine rating. When you carry a passenger, you now need a glider rating. When you fly multi-engine with the passenger, you now need a multi-engine rating. But if it's an experimental aircraft, flown single place, no ratings required. You don't even have to have a glider rating to fly an experimental glider. Any certificate will do as long as it's a private or something like that. You can fly as a glider without a private certificate. You can fly as a glider with a private certificate without a glider rating. All of those options apply as long as it's a single place. The rules change when you start. The FAA says we've got a lot of really good options for you. You can select any one of those methods by which you can kill yourself. But we have some other impositions if you want to kill an additional person. So when you want to kill one extra person, you got to get some other ratings to do that. So I'm kidding. The airplane is totally capable of flying with some reciprocating engines. Our passion is towards the electric, but we got a couple of guys. The guy that's got my biggest attention is he would like to put 2 of these radial engines. There's a couple different radial engines out there. They're from the model airplane industry, 23 horsepower each, 1 on each wing. If you listen to them in the models on the YouTube video, they just sound like a little miniature Pratt & Whitney. It's really cool sounding. And he's got my attention. I actually kind of like him, 2-engine radial powered. I think that'd be awesome. So we may see some of these other guys developing some of these power plants as well. The way that we are working the power plant system is we are working with other manufacturers that want to be power plant manufacturers for this type of aircraft, and we will take their product, put it on the airplane, flight test it, advertise it. That's a really big advantage to them. Our website right now on a very consistent basis is 1 million hits a month. We get a lot of traffic through our website. A lot of people interested in this, a lot of foreign interest in this stuff. And so these manufacturers that want to play, we're not going to do R&D for them. We're not going to buy their product, put it on the airplane, and see if we can make it work. If they want to play, they'll give us a motor that we can use. We'll put it on. If it blows up, that's on them. But I've been around this show for a long time. I know how much time it takes to get a product really well developed. I'm not going to pay for their R&D. They can pay for their own R&D. I'm willing to help them. The website is electricmotorglider.com. The progress blog is where most of the traffic goes. Go to the progress blog, and pretty much on a daily basis, I am blogging about what's going on in there. Lots of pictures and videos. There's a YouTube channel. You can click on the YouTube channel and see the latest YouTube videos that are on there. Very kind of fun to do that. It's all you can tell when I'm getting stuff done in the shop. The progress blog starts to kind of fade a little bit. When the progress blog is really ginning up and there's lots of information, you can correlate that usually directly with the Weather Channel. When it's really miserable outside, I'm back in here on the computer. When it's the other way around, I'm out working on the airplane. So, but that's where to go for that. electricmotorglider.com. What's this one? Oh no. This was test flight 31. We got a dipstick at the airport, Carl, our buddy. He was going to help me. He wanted to help launch the airplane. So he's on the wingtip out here. I forgot to tell him it's important to let go. I thought that he knew that. So now I'm off to the side, finally recovered. My rope is now underneath one of these reflectors, and it shoots the reflector up out into outer space out there. Everything went fine after that, but I now explained to my wing runners that when we get up around Mach 2, just go ahead and let go. So it didn't work very well. The rest of the flight was pretty uneventful, but I'm going to turn the volume down here, and I'm going to start to take some questions. I'm going to introduce Daniel. Daniel, why don't you come on up here? Daniel has been doing all of the motor development. We call him the motor guy, and so I'm sure you'll have some questions that he'll enjoy jabbering about as much as I do. But let's go ahead and let's take some questions. Yes?
I was wondering if I could do a winch run all by myself. You have somebody that operates the winch?
Yeah, what we're doing right now is it's just auto tow. So we have a little 400cc Honda four-wheeler, and we hook on a 1,400-foot rope, and off we go. Launch is great. We got a little receiver hitch, fits in the back of a car. There's lots of winch launch stuff. In fact, there's a paraglider company, a guy you'll see on YouTube, that's got a garage door opener that runs the winch on the ground, and he pushes the button, runs with the paraglider, launches up to the top, and then when he's all done, he disconnects and pushes the button on the garage door opener, and it reels in the reel down on the ground. He goes cruising around and comes back and does it all by himself, self-contained. Something like that might work, but right now with what we're doing, it's all auto tow. We're just now starting to get into the aero tow stuff, and that'll be a different story. But yeah, actually, Cloud Street is one of the companies that makes a pretty powerful winch that will haul a big airplane into the air. And so Cloud Street, they'll do the tandem. Usually it's got to be capable. When Jason is doing the towing, we've got a pressure gauge on the truck so we can see how much tow pressure we got. And when we're at 1,500 feet a minute rate of climb, we're how much? 200? 250 at 1,500 feet a minute rate of climb. That's how much pressure is on the rope. So the winch needs to be able to do at least 200. 200 will do it, but we can't get 1,500 foot a minute rate of climb out of the thing. And the rate of climb really isn't important as long as you got enough distance. But we're a real short 2,300 foot long strip, and then we get to run out into the weeds. And with 1,500 foot rope, that's just about right. If we're 40 miles an hour, we can almost always hit 1,000 feet if we want to. So that's how we're doing it. We're going to develop some other stuff. Other people will develop stuff too. Yeah.
Does anyone else float it than you?
I'm the only. It's all still in test flight, and I don't. Yeah, we're getting close, but I'm not worried about that. That'll be pretty easy to transition into flight. I am now at the point on the launch. The last couple launches I've done, pull to launch, let the airplane transition to climb, take my hands off the stick. It'll go all the way to the top of the arc without touching the stick. I'm still on the rudders a little bit. Get to the top, cut the thing loose, and then reach back over and grab the stick. So well balanced that it will do a complete launch without you touching the thing. So we might have a new training program where we zip tie their hands to the side of the airplane, and then I don't know. Go ahead.
What do you do about this?
We have deposits, and people are starting. Right now, we're not promising any kits till the first of the year. I think the 15th of January is our first promised kit delivery date. But we've got a couple guys that are wanting to do a lot of the build themselves, and they're starting to receive plans and building parts themselves for those kind of guys. And I want to get more of those guys because those are the guys that are going to be putting in the labor. We'll get more airplanes out there sooner that way. We still have to build frames, and we have to do that. It's a pretty small shop right now, so that's where we're at.
How many pounds of battery and charge time?
Oh, that one. He likes that.
The Part 103 power system is 33 pounds of battery, double that for self-launch. The charge time depends a little bit on what you want to spend on chargers and power supplies and how much AC power you have available. With the charge system we're using today, and we are following our philosophy to do commercial off the shelf, we're using an FMA PowerLab 8. And with that, we can charge 2 modules per hour. Now, you can stack them up and put them all on the same charger and walk away from it. So if you have a set of 8 modules to self-launch and another set in the airplane, you go fly, you leave the 8 on there and it'll take 4 hours. If you buy more chargers, it takes less time. The minimum's about an hour because of the way we want to treat the batteries.
I'm still a little confused.
Follow up.
The 23 pounds, the batteries will charge in an hour.
Yeah, 33 pounds, and they will charge in 2 hours. That's 4 modules, so we're charging 2 modules per hour with a single charger. If you buy more chargers, you can charge faster.
I was over at Redbird, and they've got a demo there for electric. They said they're using Tesla batteries. And I was over at Pickensville, and they say that they make their own batteries and put it in.
Yeah, the question was, there's a couple other manufacturers that are using other battery technologies. We have chosen to stick to middle-of-the-road hobby batteries. One of the ones that was mentioned in the question was the Tesla battery. The Tesla battery is about 25% more energy dense than the regular middle-of-the-road lithiums that we are currently using. But they also require an active battery management system and an active cooling system. And in fact, you have to work with Panasonic and have that certified to do that.
By next year, our goal is to have 3 airplanes flying here with 3 different power plant systems in effect. One of them we hope will be that small motor that we're doing right now that we're testing, that Dan has been developing. We're going to try and do that as a tri-motor configuration. Motors actually with the batteries out on the wings, no wires even going. Battery modules with the motor, the controller, the batteries, everything in a pod. Click, click, fits onto the airplane. 2.4 gigahertz transmitter controlling it from the cockpit wirelessly. All off-the-shelf on the airplane stuff exists this second.
Volts and amps?
Volts and amps. We are running, for those that know the nomenclature, it's 14S when we fly, which is under load going to be about 56 volts and 300 amps. The next generation power systems will probably be heading for more voltage and less amps. It depends on the availability of off-the-shelf speed controllers. But volts are good, amps are bad in electrical systems. Follow up.
And of course, what capacity battery packs did you build?
So they're built up out of individual packs that are 7S 5000. The Part 103 system ends up at 14S 40,000 or 40 amp hour if you prefer. In the back.
It sounds like you're using black batteries.
Sorry.
You're using black batteries, different color batteries.
Yeah, so the question is what kind of batteries? We're using generic off-the-shelf hobby lithium polymer. We are at this moment not using lithium, manganese, cobalt. We're not using any of the more energy dense ones because we're trying to stay away from the exotic stuff. That will evolve, and we will get there as the battery technologies become more mainstream. But as Brian said, everything we're using, batteries, speed controllers, cooling systems, motors, props, every last bit of it. 800 number credit card, it's on your front porch in a few days. We're using nothing exotic. So follow up? Yeah, one of the things, the question was thermal runaway, and that is famous in lithium batteries in high discharge. One of the nice things, because we're trying to get duration, is that we are at what's known as a C rate of discharge, which is the amount of capacity you have divided by the amps you're putting out. At max power, we're at about 4.5 or 5 C, which is nothing. Hobby batteries today are selling for 60 and 80 C. At cruise power, we're at like 3 C. So we just do not have thermal problems in the battery system. The other thing we're doing is intentionally paralleling the batteries, which is an old practice in the lithium. They used to be that way because the high C rate batteries didn't exist. Depending on how long you've been around lithiums, you may not have run into packs that have parallel. We take the off-the-shelf packs, build them into modules that are parallel with a thing in it called a polyfuse. It's a conductive polymer that is basically a self-resetting fuse. So if we have a problem, we're not going to burn anything up because the fuse will open. But in normal operation, operation, the batteries are supporting each other. It's probably an overstatement to call it a passive battery management system, and passive management is probably an oxymoron anyway, but that's what we're doing, is paralleling the batteries rather than going with a complex battery management system, running them at a very low C rate. Oh, there was a question over here.
Oh, yeah. Did you look at any other motors, like the Joby motors that, I guess they're almost local to you guys?
Yeah, we've looked at a lot of different motors, and while we specifically mentioned them, I don't know that we ever said the words. Well, you did. Plettenberg, Predator 37, and then the Nova. We've looked at a lot of motors. And part of the deal is commercialization, shipping. Are they available?
My thing is, I don't want to be R&D for these guys. You know, I'm just not interested in doing that. If they want to play, partner together, they can do that, but they got to develop something that really works. Right now, what we've seen with a lot of the motor developers right now, they're building stuff that's out of other kinds of stuff that doesn't have a lot of proven life or viability, and so the failure rates are pretty high on the electric motor because they're trying to do that. I want the manufacturer of that product. If it's really that great and they're going to charge me all that money, let's see, let's prove that. You know, I'll sell their product. It will sell if it's quality stuff. I don't want them to give it to me. I'll just test it for them. If it works, it works. If they don't want to play at that level, I'm not even interested in dealing with them. So that's where we are. Yeah. Yeah, so what we've done on the airplane, well, this is a different picture of just the pure glider, but you'll notice the fairing that's on the back of that. Where the motor is, there's a carbon fiber fairing that goes over the motor. So there's a lot of residual airflow that makes it around me as the pilot and goes into that back plenum. All of that gets directed directly over the motor. So we have a really high flow rate of air going over that motor for that very specific purpose. One of the flights that we had recently under power, we had the motor shut down, and the reason for that was that the ESC has an internal 100 C thermal sensor in there, and when it hits 100 C, it just shuts off to protect the electronics. Well, we've since modified the ESC. We've machined out the base of the cooling fins, and we now have an off-the-shelf computer CPU cooler bolted it out and a couple of fans on the thing, very lightweight, working awesome. The temps are really far down there, and I got that on video. You can see that. You see that whole failure process that occurred on that one part. Let me just show this one video, and then we'll continue on here real quick. How are we doing on time, by the way? So this was short field landing demonstration here on an accident. So what happened is one of the spectators decided to park the car right in front of where I was supposed to land, and so I had to kind of change plans. But this was on the third test flight right here. So here's touchdown and stop. So that's your landing distance for it. Okay, more questions? Yes.
How well does I noticed there's a Schultz controller that you're using. How well does the sensorless work with the startup? I know that sometimes it's a rough startup with the sensorless.
Yeah, the question was, how does motor startup work? On a sensorless, brushless motor, the controller is making the motor turn by sending the right things to it. When it tries to start that motor from 0 RPM, it doesn't know where it is. So the controller has to send the pulse toward it, let it kick a little, and then figure out from that kick how to turn it. So some controller motor combinations have very rough startups. The Schultz is very smooth.
Very smooth.
Yeah, very smooth startup.
The Nova is going to be a censored system.
I think there are still some censored systems out there, and in fact, you go back far enough, they were all censored. Sensorless came along where they read the position through the motor's back voltage, through the phase you're not powering. There are still some censored around for very high power systems, but in all honesty, the world's going to go sensorless. It's the trend. Almost all of them are there.
Okay, soapbox once again here. I believe we are at a stage in the evolution of aviation right now that is equivalent to the change from when we went to reciprocating engine, big radial constellations flying across the pond to the jet age. Think about this for a second. These motors that we are using, direct drive, 3 bearings, 2 moving parts. That's it. The guys that were building in the article in Kit Planes, I think it was, that were building the Cessna 172 electric, they anticipated the TBO on their electric motor to be 30,000 hours. When we start talking, and think about this, on our little motor, as long as we don't cook it, a complete overhaul is the cost of 3 bearings. There's nothing in there to wear out, it's 3 bearings. That is compared to the 4 bazillion parts in an R4360, this is a big paradigm shift. And when we start talking about developing these to the point where we get reliability, because of the small number of part count on these motors, we're going to see the reliability. I mean, when was the last time you turned on your light switch and it just didn't work? I mean, these are pretty simple, you know. Your ceiling fan runs for 100 years. When we get that spot, all of a sudden we're going to see, you know, in the ultralight industry, there was a couple of really big problems that made it difficult. Number one, noise. Massive amount of noise with those 2-strokes. Oh my God, it makes it. That's why I can't hear to this day. Number 2, engine reliability. We make most of our money teaching these maintenance classes on teaching people how to keep from not blowing up their 2-stroke and 4-stroke engine. Just so complex, so much to it. On this thing, there's nothing to, there's a little switch. It goes up, you add power, you push it down, it less power. That's how simple this is. This is a really, really big deal. The cost effectiveness of this thing. We figure right now with our battery pack, how much it would cost to charge the thing? $1 for a flight. That's how much energy we're using, $1 for an entire flight. I mean, that's a big leap from where we've been in the past. The environment is changing daily. I mean, in California, you can't even own a 2-stroke boat anymore. Those motors are outlawed on every lake. 2-strokes are going away. You see Rotax pull away from all but the Rotax 582 right now. No more of the small motors that we have anymore. So reliability, noise, economic, environmentally friendly, there's a bazillion reasons why you can see this just taking off. You know, especially think about this distributed power. You got 8 engines out there, you know, lose 4 of them. So what? You know, it really does change the dynamic of this whole world that we're talking about right now. And I think we're on the cusp of a significant change, and we're going to see more and more. It will all happen in the small stuff first. We know that. Yeah. Yeah, the vibration is really, it's amazing in the airplane. You turn the thing on. In fact, a couple times I'm up there, I can hear it, but I don't feel anything like this.
Yeah, if you watch the videos very carefully, there's a phenomenon in GoPro known as jello that comes from vibration. It's a wave down through the video. And if you watch the videos very carefully, there's jello when he's being towed from the vibration coming up the rope. When he clicks the tow rope off, the jello goes away. Powers the motor up, it's still jello.
Jello, I didn't know it was called Jello. I like Jello. I like cherry Jello. We can't. We are 56 flights on the airplane right now, and we're still in flight test phase. And it's not responsible to be doing, and we're a tow. We talked to EAA, and they actually asked if we could do a ground tow for a demonstration purpose on the main runway. But we're still a little bit early to be doing that at this point. So next year, if we're not flying by next year, we'll probably be out of business. We're going to plan on doing some significant flying next year. Yes? Cost? Okay. Plans built, we think you're in the $10,000 price bracket. If you can weld, $12,000 kit. Rector set kit, 16. Yep. Airframe only.
You see any practical application of solar?
You know, it's kind of fun to play with all of these different, I mean, the technology in so many of these areas is just going crazy. But the thin film solar stuff right now, the numbers just don't really jive.
Yeah, that question gets asked a lot. Physics says 170 square feet, if you could capture 100% of the solar energy, get a couple more minutes, that's it. Now, what may be viable, maybe, is solar panels on the ground to charge your packs while you're flying, bigger area. But 170 square feet, there's just not enough sunlight, it doesn't exist.
I do like the concept of solar panels though. if you saw the solar challenger that flies around the world, they funded that whole project, these little mini solar panels all over that thing. A zillion of them, just all over the wings. It flies that thing 24 hours. And for each one of those solar panels, there's a little name engraved there. You can sponsor a solar panel. I don't know, it's probably $5,000 a panel. I thought that was some unique marketing right there. They probably got more money than they need based on that whole process. You had another question there somewhere. Yes?
You said a kit for 16,000. Does that include the engine?
No, I told him that's without power plant.
Okay. So
And right now, the guys that have started building, they all know very well that we're still developing a lot of this power plant stuff, and we told them, go ahead and continue to build, don't choose a power plant system until we get you several choices that are out there. And the whole next step now is to start to develop these different power plant packages, and we'll develop this Plettenberg thing into the tri-motor, the twin engine version, and all of that kind of stuff, but that's, we're early, we're really early. The enthusiasm way outweighs where we are in the production of this thing.
First of all, I congratulate you on the foresight of
Well, thank you. I always like to hear that.
the other thing is, maybe an unfair question, what do you anticipate the cost of
What the power plant cost? Dan, well, let him talk about the Predator motor power pack.
Yeah, the Predator system, we expect the sustainer, and take this as a very round number, to be in the $6,000 range for the sustainer. That's 4 modules, the ESC, the motor, the prop, the charger, everything, double that for a self-warm system, roughly. And a lot of that cost is, a fair amount of that cost is battery, and we expect both the performance to weight and price performance to continue to sink over the years.
The $16,000 price that you mentioned, does that include the fact that you still have to do welding on it?
No welding on that, and that's a Rector set. We say $90 to $200 depending on your level of experience having done that. If you've never built anything before, probably $200 assembly time. You're going to be pop riveting the fuselage together, about 1,100 rivets on that, but that takes half a day to do that. Everything else is just bolt together. Pretty simple. If you've ever built a Quicksilver, we think you'll do it in 90 hours pretty easily.
You're planning interchangeable power systems, so you can on a flight mission go with a gas engine and then have the same amount?
Yeah, his question is different power plant systems, and what's really fun about this project is the possibilities, from hybrid to gas electric, conversion, multiples, 1 gas, 2 electric, use the electric for the launch with small battery packs, but you got lots of power, and then some reserve battery pack. If your cheap motor that you bought in the back that's gas powered quits on you, you got a little extra to get to a safe spot. It's really exciting to think about all the different possibilities that we've got going on right here. And the whole idea about it being modular. You decide you want to upgrade, pull yours off, sell it to somebody else that's just getting started, and go with the newer technology. Just be able to continuously upgrade. It's going to be this evolutionary process for quite some time. This is the dawn of the electric age, really.
First, you used a word I didn't understand. I think it started with a G. Yeah, okay, that word means nothing to me. But absolutely modular. That's all I wanted to say. Any other question?
It just depends on your flight mission. Those guys that are thinking about gas right now, they really would like to do some cross-country flying.
Yeah.
And if you're doing cross-country, right now, like you just, like you doesn't want to.
I get a whole lot of gas.
It'll be neat to see what's happening. Yeah. In the ultralight area. So if you want to come see us in the ultralight area. All right, guys, I think we're done. Business cards and brochures.